Okay, we continue our lecture. So next step, we will try to this. So far, we remove the edges. So those points are the corner points, basically. Okay, and then next step, we will try to find for each point, each corner, we'll give it a page. The center will be the corner point, and we'll give a small patch, small region, and we'll find the major rotation angle for each page. First of all, right now we have each point, we try to just keep the corner points. But for each corner, we have one page. The center is the corner. And for each page, we try to find the rotation angle. So each one is rotation angle. I say again, why we need a rotation angle, because when we do the comparison here, so each corner, we formulate a page. For each page, we have a major rotation angle. Based on the rotation angle, we will rotate it back to the 0 degree. So each one we will rotate to the 0 degree for the comparison. 你把这每个 page 你都有一个主要的旋转角度，这待会马上讲。这旋转角度我们把它旋转到0度，才办法做比较啊。这样子，回到这边，这样子。好，那我们就开始讲这里。那 How can we find the rotation or orientation angle? Okay, so the method is this one. 这里面有很多技巧哦，这里面很多，这就是 SFT 里面有很多技巧是可以用在不同的地方。好 ，So we have a corner here, right? We have pick， 我们有个那个塔，一个 pick here，and we try to find 19 by 19, for example. This is a page. Okay, so here, so we have a page here, and then this page. So suppose 19 by 19, and in the page, remember each point have a magnitude. When we do the gradient, 刚刚有提到一个重点，你在做那个不管是做 DOG 或做 Sobo, any kind of you do the filter, any pixel has a magnitude. Just it delete a small magnitude. You want to keep the edge. But back to here. So after threshold, so some edge will become the 0. So we will keep the higher magnitude value, so become this one. So 19 by 19, we have a magnitude for each pixel. And then because the corner is to the center, so the center points, center pixel is the most important one. So we use the mask, or we call it Gaussian weight, Gaussian distribution weight. So the weighting in the center is high. So we have Gaussian distribution, 2D Gaussian distribution. So the summation over entire width will be 1 because the Gaussian distribution. Okay, so based on this Gaussian distribution become the weight. So the weight, so each magnitude, each pixel, the magnitude for each pixel, we multiply the corresponding weights. The final we call weighted gradient magnitude. 这个名词你要学会用哦，哈，这种英文名词 we call weighted gradient magnitude. Okay, so more the close to the center is important. Okay. So this one will become the y-axis for this distribution. And because it's the edge, so each pixel has that angle, rotation angle for each pixel. So we accumulated the rotation angle, so become, suppose we have a 0 degree to 180 degree, but the bin is too many. So suppose we have only 36 bins. original, suppose we have a 180 degree for the rotation, but this bin is too many. So suppose we only have we become like a 36 bins. That's meaning 5 degree become 1 bin. So each 5 degree become 1 bin. So we have a 36 bins. So if suppose from degree 0 to degree 4, it will be 1 bin. So if any pixel level, their rotation angle is between 0 and 5, 4, sorry, 0 and 4, we accumulate the magnitude. 就是说我每5度一个 bin， 那你的旋转角度如果是在属于这5度，我们就把这个5度里面所的在这个19乘19里面的 magnitude 全部相加在一起，就变成它的 magnitude 总和 magnitude 总和，那就形成 this will be a histogram here. Okay, so you need to know how to formulate this histogram. Okay. So based on this histogram, we pick up the highest one. So this peak will be the rotation angle for this page. So suppose the picker is here, and the picker belong to bin 1. So bin 1, the angle rotation angle 0 to 4. So the rotation, this one will be bin 1. So we have for each peak, we have corresponding rotation angle. So that's for this page. But sometimes if there's a peak or this magnitude, and according to their experience, they find if any peak is more than 80% of this, the biggest peak, and there will be the second rotation angle. So each page has probably 1 or 2 rotation angles. So that's meaning, so for example, okay, this one, the pickup around here, the bin, this bin 0 to 36, and suppose this probably the bin 3 or bin something. So probably this, suppose it's 30 degree and this is 155 degree. That's meaning your rotation angle for this one. Suppose this, if this only has 1 bin, the rotation angle back will be here. If they have a 2 bigger peak, you should rotate it 1 time and also rotate it the second time because it's possible. 就你如果这个 rotation angle 有一个大的 bin， 那另外一个 80% 的 bin， 它有第二个大于 80% 的第一个 bin 的那个 bin， 那这样你这个 page 就有2个 rotation angle 都要去比，这是他的经验。好，因为你要做比较嘛，就 correspond. So I say again, if the purpose is this way, if this image and this image, are they similar? If they are similar, that's meaning there are many corresponding pages. This purpose. If both are similar, that's meaning the corresponding page has a meaning. If they have this corresponding page, that means they are not similar. This is similar. Okay. So based on this concept, so the rotation angle become important for the comparison. So finally, we have a corner. Each corner we have a rotation angle, and finally we will do the descriptor. So the descriptor is this way. The same, we use histogram, and this uses angle. So here they use 16 by 16 pixels, this page. But why this is a 19 by 19 and this is 16 by 16, I don't know. 我实际上不觉得这个干嘛19乘19，你就全部用一样就好了。但是我不晓得他 paper 就这样写。 this according to their experience, they say 19 by 19 is the best. But actually, I feel this one should be the same as this one. It's easy. Okay, we're back to here. So suppose for the descriptor, they do the 16 by 16. And then they divide it by 4 by 4 small part. We call subregion, small region. So it's 4 pixel by 4 pixel. And each small region, they have only 8 rotation angle for 8 bins. For each small subregion, they only have a 8 rotation angle. So here, okay. So they have, because it totally has a 16 4 by 4, 16 regions. This is one page. We divide it by 4 by 4, 16 small region. For each we call subregion, they have a 8 bins. It's meaning 8 rotation angles. So for each rotation angle, they accumulate their magnitude. So that's the final result. So the descriptor is a 128 bins. It's the descriptor. 这128个 bin. 就128个 dimension. And each bin has the accumulation of their magnitude, the 大小. So this will be their descriptor. A final step is so the descriptor here we call, suppose V. This V. We need to normalize to become a unit vector for this one. So V should divide it by the total summation of this V. So become a unit vector. So this final result. Okay. So that's SIFT. This final result of Y. Okay. So the dimension for this Y is 128 bins. And then this is a unit vector here. So unit length. Okay. So that's SIFT. So the application for SIFT is this one. So suppose here we have a 1, 2, 3, 4, 5 corners. Here only has 3 corners. And we compare the similarity base. First of all, we need to rotate to 0 degree. And based on 128 bins or 128 dimension, we do the comparison. 就是你每个 page 要跟这3个 each page to compare with the other 3 pages and try to find whether anyone is similar. If anyone is similar, we'll do the connection. So each one page will compare with the 3 and pick up 1. The second one will pick up 1. But there are 5 here and 3 here. So first of all is that we compare it from left to right, and then we compare right to left. If it consists, then we'll connect together. Okay. First of all, we compare the left 5 to right 3, and then we compare 3 to the other 5. If the corresponding page is consistent 一致的话，那我们就称为这是一个 corresponding 的点，就把它连在一起这样子。速度很快，这可以做 real time。We talk about this look like a complicated. No, we can run in real time. Okay. So this corner, those points are good corners, good features. It's good features, and we do the comparison. If I give you one image here, and how can you find the matching images for this one? Because there are more corresponding point in between. Okay, and the other application we do stitching. So how can we stitch together? 我们怎么做拼图？ So we find a corresponding point, corresponding point, corresponding point. And based on corresponding point, we do the rotation, we do the scaling, and we merge together to become stitch. Okay. And the same as this one. Okay, we have different kind of a small region. Okay. Based on the SFT, we can do stitching. And we do the blending smooth together. So the same here, do classification, do the stitching, merge together. Okay, for identify the target. So a lot of application. We also can apply to AR. Okay, that's for our. And this the other amazing one. I don't have enough. Next time I show you this one. Okay, so this is for the SIFT. And we talk to the next lecture.